Myself S. Premanand, working as an assistant professor in Hindustan College of Engineering and Technology. Today we would like to see the topic of control system. In control systems we have several topics. Today we will discuss block diagram reduction. So block diagram reduction, basically when you want to solve any transfer function, we have to convert everything in with respect to the block diagram mode. So we often represent control system using block diagrams. So block diagram consists of blocks that represent transfer function of variables of different interest. That is, we can allocate any variables according to the mathematical equations or the applications based upon which we assess. So if a block diagram has many blocks, we cannot say all our blocks should be in a cascade mode or all the blocks should be in a parallel mode. It should be a combination of both cascade and parallel. Either some of the blocks should be in a serial mode or some of the blocks in parallel, or in between we have summing points. So all these should be, we have to convert or we have to reduce into as a single block. So our main objective is, so we have several blocks of mathematical expressions. So all those things should be converted in a single block. So for that we have several formulations. So we will see one by one. For example, we have you can go through this figure. So we have H1, H2, H3 and H4. This all four blocks are not in a cascade. We can say in a cascade, but in between that we have some kind of branch point. So we have to remove that particular branch points and we have to make it in a single block. So we will see how we are able to see this entire block H1, H2, H3 as commonly has H1 or HZ. So we will see as H of S. So we have a transfer function with respect to the Laplace. So we will see how we will convert all the four blocks into a single block. For that we have the formulas with respect to 8 to 9 different rules. The first thing is, if the two blocks are in a cascade or either in a serial arrangement, we can have multiplication. So if the blocks are in a serial mode, we can able to say first block and second block we can able to multiply. The first block the given is G1 and second block the given is G2. So you can able to multiply G1 into G2, or either G1 into G2 or G2 into G1. So this is the way we can multiply and make it into a single block. This is the first formulation. And the next one is, you can see, is the blocks are in a parallel. If you see the blocks are in a parallel, that is one by one, we have to see the summing point, which representation they have given, either plus plus or plus minus or minus minus. This is when the blocks are in parallel, it is completely a addition rule. We can take it as addition rule. If it is both are plus, we can directly write G1 plus G2. If it is both are minus, we can write minus G1 and minus G2. If it is G1, with respect to G1 it is plus, and with respect to G2 it is minus, we can write it as G1 minus G2. It is simply like addition rule. So if the blocks are in parallel, we can have based upon the symbols with respect to the summing point, we have to write it as first block plus second block or first block minus second block. We can have a first and second block. We cannot multiply over here. It is only we can have a summing as a formulation. Okay, this is the second one. And next one is moving a summing point behind a block. So the thing is, we have to see the position of a summing point. So if we have the block as G, the position of the summing point is behind the block. So behind the block, it is the summing point is behind the G. If I want to make this summing point should be the ahead of G. So if I want to replace this summing point should be moved. I want to solve some methods in the formulations in several problems. I have to interchange. This summing point should be fixed in somewhere. Then only I can able to solve the problem. I will see in the next presentation the sums in detailed way. So if I want to move that summing point ahead of G. So what should I do? The input element is x1 and the input shall the summer the given is x2. It should not be, the end result should not be changed. You can put ahead or behind, but when you calculate the output answer, it should not be changed. So now we are going to move the particular summing point ahead of the block. So if you are moving the ahead of the block, whatever the content inside the block, that should be added as it is in the x2 terminal. So here inside the block is G, so when you are moving towards ahead of G, we can directly add a G over there in the summing point. Okay, in the same way, the next rule, we can like summing point, we can able to move the branch point also. Either the branch point is before the G or after G. So the G as in a block, so I can able to move behind G or after G. Here the fourth rule is we are just moving behind G. If you are moving the behind G, it should be added as it is G itself. And next formulation, if you are moving ahead of the G, it should be the reverse of the particular element present inside the block. That is ahead of G. We are moving the behind point should be we are moving the ahead of G. So ahead of G, it means we should have reverse whatever the things present here, the present elements inside the block is G. So the reverse point is 1 divided by G. So it should be 1 divided by G should be added in the particular branch point if you want to shift it ahead of the times. Okay. And the next one, as we see the summing point before the block. Now you should see the summing point is in the ahead of the block. It should be how we are moving to the before the block. If it is before the block, it should be added as 1 divided by G. It looks like the vice versa of the branch point and summing point. If the branch point is moving ahead, I can take it as G itself. If the branch point is moving behind, I can take it as 1 by G. So it is a vice versa with which the branch point I am supposed to move ahead, I can take it as a 1 by G. The same branch point I can bring it up behind, I can take it as G. It is a vice versa of the summing point. If it is ahead, it should be G. If it is behind, it should be 1 by G. I hope you understood. Whether we are moving with respect to the block ahead or behind. If it is summing point ahead, it is G itself. If it is branch point is ahead, it is 1 by G. That is, the concept is totally vice versa of against the concept of branch point. It is totally reverse things. I can say it as if you go through the four formulations, you can visualize the same way we are saying that ahead at once at G, and the same way ahead at during summing point, it is